This is 2014 FRQ number 2 in the calculator section. Let R be the region enclosed by the graph of f of x and the horizontal line y equals 4. So this is f of x, this is y equals 4. All right, find the volume of the solid generated when R is rotated around the horizontal line y equals -2. So y equals -2 is down here, which means from -2 to here, that's my big radius, and -2 to f of x is my little radius. So part A, we're using washer. So big radius is top function minus bottom function, so 4 minus -2, okay? Little radius is top function, which is f of x, x to the fourth minus 2.3 x cubed plus 4, minus my axis of rotation, -2. So clean this up, this gives me 6, and clean this up, x to the fourth minus 2.3 x cubed plus 6, all right? And now the volume is pi r squared, right? So pi of big R squared minus little r squared dx. But where am I integrating, right? What's the first intersection? What's the second intersection? So I don't know that. That's why this is the calculator portion. We're going to graph this out and see if we can figure out what the intersection is. So y equals 4, and then x to the fourth minus 2.3 x to the third plus 4. So first of all, I'm going to go standard window. So there's my y equals 4, and there's my graph. All right, so obviously this is too tiny for me to see, so I am going to change my window a little bit. Okay, I don't need too much of the negative, so -0.5. It looks like it was pretty small, so I'm going to go with 4. Okay, and then y, again, don't need too much of the y's, maybe 5. We'll see if I need more, right? All right, this is looking very good. Okay, so now I need to know the intersection here first and intersection there. Second calc, intersect. All right, this is my intersection. This is gonna give me 2.3. Awesome, exactly 2.3. How about the other intersection? Is it truly at 0? You cannot say it looks like 0. You have to actually see it, because if you assume it, it may not be exactly 0. It could be 0.01 something, right? So let's try to get this as close as possible. Okay, I think that's my intersection. And come on. All right, so that's a 6.25 e to -5. So that's 0.00006 point. So it's essentially 0. All right, so this point is 0. This point is actually 2.3. So 0 to 2.3, that's my interval. Okay, now I can use my calculator. Go math 9. All right, my function is 36 minus parentheses x to the fourth minus 2.3 x to the third plus 6 close parentheses, this whole thing squared. All right, I think that's my function. Yes, comma x, comma 0, comma 2.3, and there is my integral. Don't forget to multiply by pi, because that's my volume. So my volume is approximately 98.868. All right, so that's my volume there. Very good. All right, so R is the base of a solid. For the solid, each cross-section perpendicular to x-axis is an isosceles right triangle with a leg in R. Find the volume of the solid. Okay, so again, the idea is I would draw this a little three-dimensionally. There's my y equals 4, and there's my region. Anything perpendicular to, this is the x-axis, so this is perpendicular to the x-axis, and it's an isosceles right triangle like this, right? Isosceles right triangle. Why is isosceles right triangle important? Well, isosceles right triangle says that these two are the same, and these are the edges that make the right angle, which hence they are my bases in height. So the area for an isosceles right triangle is 1/2 any of the sides squared instead of 1/2 base times height, because base and height are exactly the same. So what about the sides? The sides are trapped in my region, right? So top minus bottom. So each side is 4 minus x to the fourth minus 2.3 x cubed plus 4, which if you clean this up, you will get -x to the fourth plus 2.3 x cubed. The 4's cancel each other out really beautifully. So the volume of this is integral from 0 to 2.3. What are we integrating? We're integrating isosceles right triangles. So 1/2 the sine negative x to the fourth plus 2.3 x cubed squared dx. I would probably take the 1/2 outside because it's a lot easier to work with, but it's really, again, an option that you can have. So math 9, my equation is parentheses negative x to the fourth plus 2.3 x to the third parentheses squared, comma x, comma 0, comma 2.3. All right. And then don't forget to multiply by 0.5. So the volume of that solid is 3.574. That's the volume. Okay. All right, the vertical line, x equals k. So x equals k somewhere here, vertical line. Divides R into two regions with equal areas. Write, but do not solve an equation that involves integral expression whose solution gives a value k. So first thing, what is the area of this? We don't know, right? The whole area of this is integral from 0 to 2.3, top function minus the bottom function, x to the fourth minus 2.3x cubed plus 4 dx, right? And I want some k that cuts it in half. So I want half of this area. So I want half of this. Okay, all right, so what is equal to that? Well, now I don't want the whole thing, I want a half. So this is some sort of k that I need to be at. So now I'm gonna integrate from 0 to some k value, right? So this is equal to the integral from 0 to some k value of the same top minus bottom, so which we already cleaned up here, negative x to the 4 plus 2.3 x cubed dx, right? And that's it. That's this, some sort of cut that cuts your region is equal to half of the original area. Okay, and it says set up, but do not solve. So yep, that is my integral. Okay, that's it.